You said 49. He said 41.
No, I said
49.98. Okay, newtons, so that's your weight. All right, so this one asks, part B, what's the net force? Okay, so we can either do the net force from the sum of the forces. So from this, which would be force of friction minus the weight. Okay, we know this one's 49.98. Do we know the force of friction?
Yeah.
Yeah, what's the force of friction?
Negative 4.23.
Negative 9.8 plus the negative 4.
But right now, without any other information, do I know the force of friction?
No.
Yeah, it's not given, anything like that. So we can't do the net force from this yet, okay? So what we have to do is do the net force from mass times acceleration. So 5.1 times negative 4.23. What's my net force?
I'll get right on that.
Okay, great. Negative 20 something?
Negative 21.573.
Okay, newtons. All right, so that's my net force. And Felon, you were correct. You could calculate then the force of friction.
Thomas, you going to hit it today?
Calculating the force of friction by subtracting or adding the force of gravity to both sides. Okay, so negative 21.573 plus my 49.98. So if I add and subtract, what do I get there?
Sick.
48 point. No.
Would it be like 20?
No, it'd be 20.
Yeah,
I think it's 28.
28.4?
Oh, 7.
07, okay.
So close.
All right, so that's my friction force, 28.4 newtons. All right, so my question, next question, does that make sense?
I think
That
so.
the weight is larger than the force of friction?
Yeah.
Yes, why?
Because it's falling.
Right, it's falling, it's accelerating downward. So the downward force has to be bigger to get a downward acceleration. Okay, very good. All right. Number 6.
I almost finished. You don't have a special license. Where'd you be? It is pretty far.
All right, case 13 shows a rock sliding and decelerating because of friction. The rock has a mass of 192 kilograms and acceleration along the x-axis of negative 3.2 meters per second squared. And then there's a series of questions. So here's case 13. You've got the ground or some rough surface. You got your rock, and it shows these little lines getting closer together as they get closer to the rock. It's supposed to represent this rock slowing down, but the motion is still to the right. Okay, motion's to the right, but it's slowing down. Okay, so what did your free body diagram look like on number 13?
Up, down, and to the left.
Okay, so up, and what do you label that up force?
F.
Okay, normal force,
Neutral.
good. Force normal.
Or normal.
Down, force of gravity, and then you said to the left,
Yes.
force of friction. Okay. What about my force to the right?
It'd be acceleration, or force acceleration.
Huh?
Is Is it accelerating?
What's that?
Is there anything in contact
No,
with it?
no.
Okay, that's where we stop, okay? Okay, no other forces, nothing else is in contact with it, no strings pulling it, nobody pushing it. Okay, we don't know what happened before the diagram, to figure out why it's moving, but at this moment, it's slowing down because friction's acting on it. Okay, so, all right, so if you look, I've got forces in the y direction, and I have forces in the x direction. And so we're going to do an acceleration in the y direction, and we're also going to do, a force and a force and an acceleration in the x direction. Okay. So we're actually going to do this equation twice. We're going to do sum of the forces in the y direction equals mass times acceleration in the y direction, and we're going to do, net force in the x direction equals mass times acceleration in the x direction. We're going to do both because we have forces in both dimensions. Okay? So that's kind of where we're going with this. All right, so we'll find the weight of the rock. So force of gravity, m times g. So here's our mass, 192 kilograms times 9.8. And what's our weight? 1881.6 newtons. Okay. All right. What's my acceleration in the y direction? Up and down. What's my acceleration?
Negative
Somebody said 0.
0.
Y 0. That's correct.
Because you're not
Moving
falling.
down.
Right. We're not moving up or down. It's moving to the right. It's slowing down. So 0. All right. So if my acceleration in the y direction is 0, what's my net force in the y direction?
0.
Also 0. Right. Okay, the net force, so the combination of these two is 0. Part D, then, what is the normal force? So looking at just the left side, it's normal force is up, so that's my positive force. Weight is acting down, that's my negative force. So positive normal force minus force of gravity, that's what equals 0. So what's my normal force equal to? Normal force, if I add the force of gravity to both sides, it's just equaling the force of gravity, so 181.6 newtons. Okay, they balance each other out. There is 0 net force, so they have to have equal magnitudes. They get 0 acceleration. All right, so I'm going to move the problem up a little bit. Look at the next one. All right. So now it asks, what's the net force in the x direction? So sum of the force in the x direction equals mass and acceleration in the x direction. Okay. Well, we were told the acceleration in the x direction right there. So negative 3.2. So 192 times negative 3.2 meters per second squared. What's my net force in the x
I'll get right on that.
You got all.
Negative what?
Negative 614.4.
15.4.
614, is that so?
Yes.
0.4. All right, great. That's my net force in the x direction. Okay, so that comes from using the right-hand side, mass and acceleration. Now looking at my left-hand side, what forces do I have acting in the x direction? What forces are acting horizontally?
Friction.
Friction. Is that a positive or a negative force?
Negative.
Negative, okay? So if I put that here for my sum of the forces, the only thing acting in the x direction, negative force of friction equals my mass times acceleration. So negative force of friction equals negative 614.4 newtons. So multiply both sides by a negative. My force of friction, the magnitude of my force of friction, 614.4 newtons. Okay, it is acting to the left, but we took that into account.
Why is it positive?
Well, negative force of friction equals a negative 614.
Why is the F
Because
Because it's on the right side. It's on the left side of the
It's pointing to
y-axis.
the left.
Oh.
It's pointing to the left, so I wrote that's that direction there.
If you would.
So maybe it should be better written as what is the magnitude of the force of friction.
Did you get that?
I did.
Good to know.
Okay, so that's that one.
That is now.
Okay, let's look at number 7. Case 16 shows a rock tied to a rope and pulled straight upward without friction. The rock has a mass of 50.2 kilograms, so that's my mass, and an upward acceleration, 5.28 meters per second squared. Okay, so force of gravity acting down. What other force do we have acting?
Up.
Up, okay. And how should I label this upward force? Is this
Uh,
a normal force, an applied force, a tension force?
I think it's
Okay, why
F of
tension's
T.
correct. Why
F
tension?
of T because of the rope.
Right, it's a rope. Okay. So force of tension.
So why is the acceleration with the up arrow?
Well, it tells me that it has an upward acceleration. Okay. So, we haven't got there yet, but should this tension be larger or smaller than the weight?
Smaller.
If it's going to accelerate
Like
upward.
larger.
I think larger would be the
We're
more.
pulling it upward and accelerating it upward, so it's going to be larger than the weight. when we get there. And we'll look at that here in just a moment. Okay, so first off, find the weight. Mass times gravity, 20.2 times 9.8.
You got that one, Jackson?
Yes, I do.
What is it?
I got 197.96.
Okay,
Oh,
thank you.
good to know, Walter.
197.96 is my weight. All right.
He was just confirming, just in case he said it wrong.
I don't
I don't know what the big deal was. I got your back, Thomas.
Okay, so it asks for the net force in the y direction. So that's net force in the y direction equals mass times acceleration in the y direction. So can I use the left-hand side and look at my two forces to find my net force? Or do I have to look at the right side, mass and acceleration? Right side, okay? Right, I'm given the mass, I'm given the acceleration. So 20.2 times 5.28. And what is that?
106.656.
Sure.
Thank you. All right, so that's my net force.
Why don't you double check?
Okay. All right, so just using the letters, the symbols here, what's another way I could find my net force using just these forces here in using these symbols? Okay, what would the sum of them be mathematically? Should I when you say sum, so do I just add them up?
No.
Why
You
not?
do, I think you do teach it.
Which direction is the force of tension?
Up.
Up, so that should be positive. Which direction is the force
Oh,
of
so
gravity? Negative.
You,
Subtract after T minus.
subtract.
Alright, so yes, so your sum of the forces, or your net force, would be an upward tension minus the downward force of gravity. That's what equals that. So force of tension then would be equal to, add the force of gravity to both sides. Okay, so 106.656 plus 197.96. And what do we get there? 305 something? 304?
$304.616.
Okay. Alright, so that's my tension. 304.6. My weight, rounding it off, 198. Okay? So does it make sense that the tension's larger than the weight?
Yeah.
Yes,
This is going up.
because it's accelerating upward. So that has to be a larger force to account for the weight. So it has to, so this tension supports the weight, and then anything extra makes it accelerate. Okay. All right, good. That's number 7. Am I giving you enough time to write
Yes.
Yeah.
down everything?
I think we're ready.
All right, number 8. Okay, similar, but now I'm given the tension. Okay, so in this case, the rock is tied to a rope, an upward force of tension is given. Okay, so this force of tension, 66.34 newtons. Mass of the rock, 10.7 kilograms.
This one maybe.
Okay, so
They also.
draw your free body diagram. Okay, what forces do we have acting on the rock?
Oh, okay, so you want us to draw it this time?
Yeah, so letter A is draw a free body diagram. Okay, so where would be the best place to start?
Probably
Force of gravity, that's a good place to start, force of gravity.
I agree.
Okay, now what contact forces do we have?
Well,
Tension
tension force.
and acting upward. Okay. Anything else in contact with it? That you? No, that's where you'd stop.
Is
Okay.
that it?
It's the baby.
All right.
It's all folks.
Then force of gravity, mass times acceleration due to gravity, so 10.7 times 9.8. And what is that? Give me.
Jackson, you got
104.86.
You said 8.6?
Yes,
Okay,
sir.
great.
what?
Okay, so 66.34 on the tension, 104.86 on the gravity. All right, so all right, so the next question, what's the net force? So, so should I use the left side with the forces to find my net force? Or should I use the right side with the acceleration to find my net force? Do you know the acceleration? No. Okay, so we have to use the left side with our forces here. Okay, so in this case, we use since we know both forces, we can use that to find my net force. So force of tension minus force of gravity equals 66.34 minus 104.86. Okay. am I subtracting them?
Because
Why is one positive, one's negative?
this one's going up.
Okay, right. One's going up, and one's going down. Up is positive, down is negative. Okay. And so what do we end up with our net force?
Negative 38.52.
Okay, thank you. Negative 38.52. All right, and then part D, what's the acceleration? So using second law equation, net force equals mass times acceleration. Okay, and since it's moving up and down, I'm labeling it Y because it's all in the Y direction. So we have negative 38.52 equals 10.7 times acceleration.
You divide.
All right, then divide.
Yep, I guess.
I'm sorry, TJ.
And
Your calculator's in front of you, right?
negative 3 point something.
Negative 3.6.
Smart guy with
Okay, make sure you put the labels, meters per second squared. There. All right, good. All right, let me ask this question. Does it make sense that it's a negative acceleration?
Uh-huh.
Yes.
Why?
Because the force of gravity is greater than the force of tension.
Okay, good. The force of gravity is larger than the tension. So a larger negative number, and it's still accelerating downward. So even though there's an upward force, it's still falling. Okay, just not, it's not under free fall. It's not falling at negative 9.8. It's falling at negative 3.6 meters per second squared. All right, good. Oh. What direction is the rock moving?
Left.
No.
Or down. Yeah.
Down. What would be a good explanation?
Because it's
the
negative.
force of gravity is greater than the force of tension.
All right, two different ways. Force of gravity is larger than the tension, or it has a negative acceleration. Negative meaning downward. Okay. All right. Okay, and this one, a 35 kilogram rock placed on a horizontal frictionless surface. So, horizontal frictionless surface has a rope tied to it. Pulling it horizontally produces an acceleration, horizontal acceleration, 4.6 meters per second squared. Okay, so we know the mass here, 35 kilograms. We know the acceleration in the x direction is a positive 4.6 meters per second squared. It's on a surface and it's not rising or falling. Can anybody tell me what the acceleration in the y direction would be? Zero. Good. It's not being lifted off the surface. It's not falling through the surface. Okay. So those are some things that we know that are given from the context of the problem there. Okay, so free body diagram. What forces do we have acting? Lily, what would be one of the forces?
Force of gravity.
Force of gravity. Courtney, what would be another force? What's touching the rock? Is the ground touching it, or the rope touching it, or is air touching it?
It'd be up.
Up, okay. Why up?
Because the ground, it's on the ground.
Okay, right. There's a surface touching it, so the ground pushes up on it. All right. Force normal. Cameron, what else do we have acting on the rock?
So now,
Tension?
Tension. Okay, right. There's a rope tied to it. Okay.
You're not a camera.
Rope tied to it.
Well, he
Force of tension.
You
Okay. All right, no friction. So, no friction force, no air resistance or anything. So that's it. That's where you stop. All right. Next question. What's the weight of the rock? So force of gravity equals M times G. So 35 times 9.8.
343.
Thank you. All right. We already determined letter C since it's
0.
on a surface. Acceleration in the y direction 0. Net force in the y direction also 0. And if we look at our free body diagram, in the y direction we have positive normal force minus the force of gravity equaling 0. So subtract force of gravity from both sides. Force of normal equals force of gravity. So normal force also equals 343 newtons. All right, so there's a couple other questions with that, so let me move it on up.
Spider-Man? Why? Because I keep saying May. I need to rewatch the movie Spider-Man. I saw it yesterday on TikTok.
Okay, so letter F. What is the net force in the x direction? So sum of the forces in the x direction equals mass times acceleration in the x direction.
This for F?
Yes, letter F. Okay, sum of the forces in the x direction, or net force in the x direction equals mass times acceleration in the x direction. Okay, so the only force acting is tension. Do we know that numerical value? No, so we have to use the right-hand side to find my net force.
So you gotta do 35 times 4.6.
Okay, thank you. 35 times 4.6. And that equals 161.
Smart guy over there.
Thank you.
Bro.
And okay, if we look at all the forces in the x direction, what should go on the right-hand side here?
That's a tough one.
What are my forces acting in the x direction?
What do you
Force
think,
of tension.
Lucas?
Force of tension.
Good job, Lucas.
And that's your answer to part G. Okay. The only force acting in the x direction is the tension.
It's raining.
Thank you. Thank you.
Okay. Any questions with that one?
Thanks for the observation.
I think I'm good. Thank you.
All right, one more.
Hooray!
On the home stretch.
Get thrown at your
It's okay. I still replay JP running home on the Episcopal game getting thrown out.
I still replay Wobble
You know what I'm talking about?
in Florida.
Freshman year when JP got thrown at home at Episcopal, that's whenever I realized how slow he was.
I still replay. Still replay Thomas setting up a grand slam.
Okay, so this time it's not a rock, it's a crate.
I haven't seen that yet.
All right. 100, so we're given the mass.
Yo, you draw that real quick?
Yo.
Hard
155.8 kilograms is my mass.
Yeah, because Cameron was
Okay,
chasing
it does say there's
ants
a
down
rough
in the do-rag.
horizontal surface. Okay, what does a rough surface mean?
There's tension.
If it's sliding across a rough surface,
It's
what
friction.
Okay, right, there is friction.
That's how I meant it.
No, it's not. That's not what you said.
Okay, so friction is present.
Ow.
Okay, being pushed with a force, so we know we have an applied force, 700 newtons, and it produces an acceleration, okay, in the X direction, horizontal acceleration of 3.9 meters per second. So that's my
Stop.
given.
Stop.
So you want to do this on your own?
No, I was talking to TJ.
Oh, okay. All right.
He keeps touching me.
Well, there's two empty tables. You can
One,
move.
two.
I think I trust him one more time.
TJ, are you touching him?
No.
Well,
Okay.
Bro.
Please keep your hands to yourself. All right. So what forces do we have acting? Okay,
applied
force of gravity. An applied force. How would I draw the applied force?
normal to the left. Or to the right.
Which one are we talking? Okay.
The guy pushing it.
All right. He's pushing it.
So it's
Pushing
that
it to
way.
the right.
Yeah.
So force applied to the right. Okay. What's the third force? Right. It's on a surface.
Friction.
All right. There's a normal force, correct, and there is friction.
It's like a compass.
You got that read right here?
All right. So
Lucas.
you know, if the motion is to the right, then that means the friction's to the left, opposing that motion. All right, so that's your free body diagram. Okay, so if you look, it does have
Fights over Thanksgiving.
vectors in the Y direction and vectors in the X direction. So we're going to use both equations. We're going to use
Lundy.
forces in the Y direction, we're going to use forces in the X direction. All right, so starting here with the weight, M times G, so 155.8 times 9.8.
What's that special?
What's that?
Price is special.
Oh, I got 6860.
Don't have it.
Yeah, it's 1,526.64.
Oh wait, he's right. I did the wrong one.
1,000 what?
1,526.84.
Okay. Thank you. Okay, what's the acceleration in the Y direction?
Let's look.
Zero. Yeah, zero.
0. Okay, good. Why?
Because it's not moving up or down.
Right, not moving up or down. Good. So what's my net force in the Y direction?
Zero.
Right, also 0. So that allows us then on the left side, normal force minus the weight equals 0. So normal force equals the weight. So 1526.84 newtons. Okay, so that's A through E. So let me move it up so we can see the last 3 questions. Okay. Everybody have enough time to get what they wanted?
Yeah.
I just need the bottom one.
Okay. Okay. What's the acceleration in the X direction?
39.
3.9.
How do you know that?
It gives us.
Right, it's given. Positive 3.9 meters per second squared. So net force in the X direction equals mass times acceleration in the X direction. Okay, so 155.8 times 3.9. And what's that? 600 something?
I don't know. Thomas?
Lucas?
What happened with Lundy? How'd that one start?
Okay, 607.62, is that what you said? Okay. All right, so that's my net force. All right. So that's using the right-hand side because I know the mass and the acceleration. But what does the left side look like? Well, the left side would be an applied force minus the force of friction equals my mass times acceleration. And we're looking for the force of friction. So, couple a couple ways if I subtract the force applied from both sides. So negative force of friction equals m times mass and acceleration minus applied force. I'm going to go ahead and distribute this negative sign throughout.
Negative 607 plus.
So end up with force of friction negative 607.62 plus 700. So what's that? 92 something?
pouring out.
92.38. Is that what I get? Okay. All right, so my force of friction, 92. All right, so my applied force, 700. My force of friction, 92. Okay. Does that make sense that the applied force is larger than the friction?
Yes, because it has to move, right?
Well, it has to move with a positive
yeah.
acceleration, so yes. Okay, so ladies and gentlemen, we will work one other type of problem tomorrow.
That's mine, TJ.
But you should have almost everything you need to work on the quest, so if you haven't started working on that or looked at it.
What's the quest due?
Tuesday.
Quest is due Tuesday, 4 p.m. It does count as a major
Do you
assessment.
need these back?
Yes, I do need the force diagram worksheet back so I can grade it.
Oh, sorry.
Helen, on a scale of 1 to 10, how bad is the math quiz?
Okay, on the quest, ladies and gentlemen,
7 being hard?